Let's start with the properties of determinants. Now the first property is the value of determinant of a matrix and its transpose is same. Now what does it mean? It means that is the determinant of A is equal to the determinant of the transpose of the matrix. Now let's understand it with the help of an example. So let's take a 2 by 2 matrix. Let's say 2, 1, 3, minus 2. Then the transpose of this matrix will be 2, 3, 1, minus 2. We know in transpose row becomes column and columns become row. So now let's find the determinant of A over here. So determinant of 2 by 2 is this multiplied and this multiplied with this and then the difference of both. So 2 into minus 2 minus 3 into 1. So this is equal to minus 4 minus 3 which is minus 7. Let's see this. Now what is the determinant of A transpose? It is 2 into minus 2 minus 1 into 3. So it is minus 4 minus 3 again minus 7. So what do we see? Both the values are exactly same. So this is what is stated in the property, that the value of a determinant of a matrix and its transpose is same. Let's start with the second property. It says if any two rows or columns of a determinant are interchanged, then the sign of the determinant also changes. Now what do we mean by the rows or columns interchange? Interchange means I will make R1 as R2 and R2 as R3. R1, R2 I address as rows and C1 and C2 I address as column. So what does it mean interchanging rows and column? It means making R1 as R2, R2 as R3, column 1 as column 2, column 2 as column 3. Let's understand all this with the help of an example. So let's take an example. I am taking a determinant over here. For this I will take a 3 cross 3 determinant because in that case it will be easy for you to understand, right? So I am taking minus 1, 2, 0, 2, 3, 1. Let's say any random determinant we can take. Now what does it mean changing any two rows? So I'll over here change R1 to R2. We write it like this, changing R1 to R2. R1 becomes R2, R2 becomes R1. So over here I'll change my determinant and write this is my row 1. If you remember, this is how we write the notations, right? So this is R2, this is R3, this is column 1, this is column 2 and this is column 3. So how do we write? Now I'll change R1 to R2. So I will write all the elements of row 2 over here and all the elements of row 1 over here. And R3 will be exactly same. So now what do I have? I'll addresses at determinant 1 and determinant 2 after applying this operation. So now let's find out the determinant of both, the value of the determinant of both. So over here, this determinant, what I'll do, we already discussed in the first video that whenever we have 0 along any row, any column, it is advisable to expand along that particular row or particular column, right? So we will expand along over here R1. So I'll write minus 1. Similar, the same way, the procedure that we followed for the first one, what I'll do, I'll cover it along row and column. So this will be reduced to a 2 cross 2 determinant. So I'll cross multiply. I'll simply write it like this. For the second one, we'll follow the sign rule. What was the sign rule? The first is plus, the second is minus, plus, minus, plus, minus, plus, minus, plus. This is the very important sign notation which everybody has to keep in mind, right? So now let's write the second element. We'll write minus sign along with it and then again we will cover it along this particular row, this particular column. These elements I will write over here. So this will be 2, 1, 1 minus 1. And for the last, so on calculating what we will get this as 5 plus 6 plus 0. So the answer of the determinant, the value of the determinant will come out as 11. Now let's see what do we get for this, what value do we get for the second determinant. So for the second determinant, if I expand it, let's observe the 0 is along R2 or let's say column 3. So let's expand it along column 3. So column 3, I'll write column 3. So what will I write? I'll write first element taking sign into consideration. I'll write 1. Then we will directly solve. We will cover it along this column and this row. So what we will get if I cross multiply? I'll get minus 2 minus 2. Then I'll write the second element. Again, what do we observe? Second element is 0. So no need of writing. We will take minus sign. We will take minus sign. So minus, and no need of writing it. And then I'll write the third element. Third element is minus 1. We will cover it along this particular row and this particular column. The left out elements I'll cross multiply and I'll write 2 into 2 as 4, minus 1 into 3 as plus 3. So what do we get? We'll get minus 4 minus 7. What am I getting? Minus 11. Yes. So this is what the property says. It says if we interchange any row or any column, the sign of the determinant changes. So this is what we are observing here. For this, the determinant is 11. For here, this, the determinant is, the value of the determinant is minus 11. So hence the second property is also verified. Now moving on to the third properties of determinant. It says if any two rows or columns of a determinant are identical, then the value of the determinant is 0. Now what does it mean? It means if the elements, the nature of the elements, or if the elements are exactly same in both the rows or both the columns, then the value of the determinant will come out to be 0. Let's try to understand. Again, we have to take a case of a 3 by 3 determinant. So now let us take a determinant. The determinant, let's say, is 2 minus 3, 0, 1, 2, 1 and 1, 2, 1. Now, what do we observe? We observe that the row 2 and row 3. I'll write it over here, R1, R2 and R3, C1, C2 and C3. Now what do we observe? R2 and R3 are exactly same. All the elements are same. So now according to the property, the value of the determinant should come out to be 0. Now let's verify. So I'll expand it along R1 because it has 0 over here. So I'll write 2, cover it along row and column. So we will cover it along this particular row and this particular column. So we will get 1 into 2 as 2 minus 2. So 2 minus 2. Let's take the second element. It is minus 3 and according to the nature of the sign, it will be minus of minus 3. So it will be plus 3. Now let's cover it along this particular row and particular column. So if I cover it along this particular column, this particular row, so what will I get? 1, 1, 1, 1. So 1 into 1 and 1 into 1. So 1 minus 1 will come out to be 0. Now let's write the third element which is 0. So no need of solving it further. So what do we observe? Over here it is 2 into 0 plus 3 into 0 and this is 0. So overall the answer is 0. So this way you can take n number of examples and verify that the value of the determinant will always come out to be 0. So in continuation to this particular property, we have one more property or you can say special case of this particular property, which says if any two rows or columns of a determinant are proportional. In place of identical, what we have? Proportional. So now the second part of the same property, which says if any two rows or columns of a determinant are proportional, then the value of the determinant is again 0. So is 0. Let's take an example. So we will take a determinant over here such that any two rows or columns are identical, proportional. Not identical, proportional. So 1 to 1, I'll take it as 2, 4, 2, and this can be minus 1, 0, 1. So what do we observe again? I have taken R1 and R2. R1 and R2 to be proportional. Now what do we mean by this word proportional? Proportional means if we divide any two row or any two column, the answer of the division should come out to be same always for all the three elements. Now what do we observe? Like 2 divided by 1 is 2, 4 divided by 2 is 2, 2 divided by 1 is 2. So it is proportional. Proportional means the answer of the division should come out to be same. So what do we observe? And this should happen for each and every element of that particular row and column. Okay, so both the rows are proportional. So now let's expand it along. We will expand it along R3 this time. So if I expand it along R3, I'll write minus 1. Cover it along this particular column, this particular row. What will I get? 2 into 2 as 4 minus 4. I'll write the second element which is 0. So no need of expanding along that particular row or column because the answer will come out to be 0. Now let's write the last element which is 1, right? Now if I cover it along this particular row and this particular column, what will I get? 4 minus 1 into 4 is 4, 2 into 2 is 4. So this will be minus 1 into 0 plus 0 plus 0. So it is coming out to be 0. Hence the property that if any two rows or columns are proportional or identical, both the value of the determinant is 0. So first thing that we have to see in any determinant is whether all the elements are 0. If all the elements are 0, automatically the value of the determinant will come out to be 0. If any two rows or columns are identical or proportional, then also the value of the determinant will come out to be 0. So again one more 0 property. Now what it says, if each element in a row column of a determinant is 0, then the value of the determinant is 0. This is very obvious property, right? If we have a determinant like this, what will be its value? If I cross multiply, I will definitely get 0. Similarly, if I have a determinant like this, again, if all the elements of a row are 0, the value of the determinant will come out to be 0 because if I expand it along this particular row, each and every element will be multiplied 0. So automatically the sum or the difference will come out to be 0. So moving on to the next property, it says if each element of a row or a column of a determinant is multiplied by a constant, let's say k over here, then its value gets multiplied by that constant. In other words, if I phrase it out, it will be like I can take any common factor from any row or column of a determinant. So let's try to understand this with the help of an example. Suppose we have a determinant. Let's take the determinant as 1, 2, minus 1 and 3. I'll take a 2 by 2 determinant. Now if this is one determinant, I'll write the second determinant where I'll multiply R1 by, let's say, 3. So if I multiply R1 by 3, it will be 3 into 2 is 6, and this is minus 1 and this is 3. So over here, let's find out the determinant. So what will be the determinant? 1 into 3 as 3, minus 1 into 2 as minus 2. So this will be 3 plus 2 as 5. Similarly, over here, 3 into 3 as 9, minus of 6. So it is 9 plus 6, which is 15. So what did I do? I multiplied R1 by 3. I'll write it like this. The value of determinant 2 is 3 times the value of the determinant 1. So if I multiply a row by 3, the value of the determinants get multiplied by 3. Similarly, if I multiply any column by a constant, the value of the determinant will also get multiplied by that constant. So what do we learn? If you can recall, in the first video we did one result which was Ka times the determinant is Kn determinant of A, where what was n? The order of the determinant.